Hello dear students, welcome back to my new video. In this video, I am going to discuss the chapter Waves, that is chapter 15 of physics textbook of class 11 ncert textbook. Okay, let's start waves. In this chapter, we shall discuss the type of propagation of waves through different media, factor affecting speed of waves in them. Then we also discuss superposition of waves and Doppler's effect in sound. Okay, let's see what is wave propagation. For that, first drop a stone in a pond of still water. Then these waves move outwards in expanding circle until they reach the shore. It seems as if the water is moving outward from the point of disturbance. Okay. Then we can say here energy is transferred but there is no transfer of medium. So, such pattern in which there is no actual transfer of matter as a whole but energy is transmitted from one part of a medium to another part is called wave. So, this is about wave and propagation of wave. Next we can see transverse and longitudinal waves. First, transverse wave. They are the waves in which the constituent of the medium oscillate perpendicular to the direction of wave propagation. Okay. If we give an upward jerk to one end of a long rope that has its opposite end fixed, a single wave pulse is formed and travel along the rope with a fixed speed. This is an example for transverse wave. Next, longitudinal wave. These are the waves in which the constituents of a medium oscillate along the direction of wave propagation. That is, the constant of medium oscillate in the direction of wave propagation, whereas in transverse wave, the constant of medium oscillate perpendicular to the direction of wave propagation. Okay, next topic is displacement relation in a progressive wave. Okay, a travelling wave is also referred as a progressive wave. That is, we can say a progressive wave as a travelling wave. It may be transverse or longitudinal. You can consider any wave as travelling wave, transverse or longitudinal. Okay. Now consider a transverse wave. So that if we travel along positive x-axis, the constituent particle of the medium vibrate along y-axis. That is perpendicular to the medium we have discussed in topic transverse wave. Okay. Then a sinusoidal shape can be described by sine or cosine function. The wave will be sinusoidal shape. Okay. At time t, the displacement y of the element located at position x is given by y of x comma t equal to a sine kx minus omega t plus phi. This is the displacement y of an element located at position x and at time t. From this equation, y of xt is the displacement of medium particles, a is amplitude of a wave, omega angular frequency of wave, k angular wave number and phi initial phase angle. Next we can familiarize some important terms related to this chapter. First, amplitude. The maximum displacement of the constituents of medium from their equilibrium position is the amplitude. Okay. Second, phase. The argument of the sine function is the phase of wave. Phase determines displacement of the wave at any position and at any instant. Third, crest. Crest is the point of maximum positive displacement on a wave. The wave is in the form sine function, then maximum positive displacement on a wave is crest. That is, peak of a sinusoidal wave represent a crest. Next, trough. It is a point of maximum negative displacement on a wave. Next, time period. It is a time takes for an element of a medium to complete one full oscillation. That is, we can define time period T is equal to 2 pi by omega. Next, we can see wavelength. It is a minimum distance between two points having the same phase at a given time. The wavelength is denoted by lambda. Lambda is equal to 2 pi by k, where k is angular wave number or propagation constant. Okay, next, frequency. The frequency V of wave is the number of oscillation per second. Okay, it is a number of oscillation per second. It is denoted by letter V. SI unit of frequency is hertz. Then we can define frequency V equal to 1 by T, that is 1 by time period, which is equal to omega by 2 pi. Next topic, the speed of a travelling wave. If we focus on a particular point on the wave and observe the motion of this point in time, we can determine speed of a travelling wave. Okay. Here in this figure, we have two single travelling wave taken in a small interval delta t. The entire wave moves through a distance delta x in interval delta t. The wave speed can be calculated using the relation v is equal to delta x by delta t. Let us consider a crest shown by point A in the figure. As the time changes, the position of the crest changes from A to B. Since the phase remains constant, therefore we can write kx minus omega t is equal to k into x plus delta x minus omega into t plus delta t, which implies kx minus omega t is equal to kx plus k delta x minus omega t minus omega delta t. Or we can write k delta x is equal to omega delta t. Therefore, we can write delta x by delta t is equal to omega by k. We are taking delta x and delta t very small. Therefore, v is equal to dx by dt, which is equal to omega by k. Because we written delta x and delta t as very small. Hence, speed of the wave is equal to v is equal to omega by k. Also, we have omega equal to 2 pi by t and k is equal to 2 pi by lambda. Therefore, we can write v is equal to 2 pi by t by 2 pi by lambda. 2 pi and 2 pi by get cancelled. We get v equal to lambda by t or v equal to f lambda. because t equal to 1 by f. This is the equation for speed of a wave.